Hello. In this video, we're going to cover visualizing numerical data. When analyzing data, one of the most important things we look at is the distribution. We ask questions like, what is common? What is unusual? What is extreme in the data? Studying the distribution helps us to answer those questions. The first step in studying the distribution is to visualize the data. In this video, we're going to look at two methods, dot plots and histograms. Okay, so let's go through and look at a data set and then, use some visual techniques to go through and analyze that data set. Okay, so here we have a data set. This data set represents the number of goals scored by NCAA women in soccer games in 2016-17. It's not all of the data that's in the data set, but it's a portion of it, and we're going to go through and take a look at it. So if you start off with raw data like this, which is just a bunch of numbers, one of the first things you might want to do in terms of visualization, and this is a visualization technique, is just to organize the data into a table. Okay, so we looked at tables in the last chapter. So let's take a look. If you just kind of expand this, I've hidden the table over here on the right. And so to go through and construct the table, all you have to do is just count up how many times a number appears. So that's called the frequency. And so if you look through this, so 10 should appear 8 times if you go through the data set. 11 should appear 7 times, 12 twice, 13 7 times, and so on. Okay, and so this is a visualization technique. We are organizing the data into a table. However, this is not what we mean by a dot plot or a histogram. So those are graphs. So this is not a graph. This is just a table. And so the method that we're going to look at first is to go through and construct a dot plot. All right. So for a dot plot, what you're going to do, let's see if we can do it in here, or if I need to jump over to Zoom. I think this will work. All right. So what you want to do is you want to draw a horizontal line and try and get it somewhat straight. All right. And then after that, we'll also need a vertical line. So what we're going to do here is we're going to label underneath our horizontal line. This is going to be the x-axis. This is the y-axis. we're going to go through and we're just going to pick places on here to represent these values. All right, so how many do we need? We need what is that? That's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, well, we went off the end of the table a little bit. That's okay. All right. So what you're going to do is you're going to go through and take the frequency and you're going to put a point. You're going to go through and you're going to put points on here to represent that frequency. So you're just going to put dots. Actually, with a dot plot, what you're going to do is you can actually go through and use the raw data for this. For the frequency, we'll end up using the table over here. We'll end up using that when we create a histogram. But for the dot plot, you can actually go through and use the raw data for this. So let's say this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So for 10, you go through, and if you see a 10, you're just going to put a dot. Keep going. There's another 10, another 10. And there should be 8 in all, and we know that from our table. And so you're going to want to have 8 dots for 10. And then for 11, we should have 7. We should have 7 dots. For 12, you should have 2 dots. For 13, 7 dots again. And so on. All right, so you just want to keep going in that fashion. So that's how to go through and construct a dot plot. Is you literally just go through the data set, and wherever whatever the value occurs, you go and you put a dot in that place. And you could do it the way that I did, where you just do, okay, 10 should get 1, 2, 3, 4, 8 dots. Or you could go through and you could put a dot in 11, a dot in 14, a dot in 16, a dot in 13, a dot in 13. You're going to get the same result either way, assuming you don't make any mistakes. Okay, so that's how you construct a dot plot. All right, let's go through and look at a histogram. Okay, and of course, we're constructing these by hand. I will show you in a moment how to use a software package to go through and do this so that you don't have to do it by hand. All right, so for a histogram, we also need a horizontal line. We also need a vertical line. All right, and then what we're going to do here is we're going to end up creating what's called a bar chart. So there's going to be bars. They're going to come up off of the x-axis here. And so for a bar chart, you're going to have a range of values. So I'm going to pick a spot, and I'm going to say this is the lowest value in our data set is 10. I'm going to start there, and then we'll pick a spot for 12, 14. We're going to go by 2s. 16, 18, 20, and 22. And then I'm going to go through and I'm going to put some denotations on here. So if you recall from algebra, this square bracket represents the fact that that number is included. And so 10 is included in this interval. And the parenthesis represents that the interval goes right up but does not include. And so the parenthesis means that 12 is we go right up to 12, but 12 is not included in this interval. And so I'm going to go through and I'm going to do that throughout these. You don't have to do this. It's just a way to denote the organization that I'm going to use for the histogram. Okay. And so once you've done that, what we can do is we can go through and say that this interval for this block starts at 10 and goes up to 12, but doesn't include 12. All right. So to figure out, how tall a bar we're going to put there, we're going to go over to our table and we're going to add up the values that are in that interval. So that'd be 10 and 11. So we're going to get 15 as the frequency, 8 plus 7, 15. And so we want to draw a bar that is 15 units high. Okay, and then from 12 to 14, we've got 9. So we want to draw a bar that's 9 units high. All right, so let's go ahead and put some markings on here. So we've got 15. We'll try to divide this into thirds. So we'll say this is 10 and this is 5. And then so if we want to go up to 9 for the next interval, right? 2 plus 7 is 9. All right, and then for the next interval, we've got, so that's 14 to up to 16, but not including 16. So that would be 14 and 15. We get 6. So 6 is going to be a little bit above 5. All right, and then 16 to 18. So that's going to be 16, 17, but doesn't include 18. So we're going to have a bar that's going to have a height of 3. We'll say that's about 3 there, right? And then from 18 to 20, we've got 3, but not including 20, we've got 3 again. Oops, that's the next one. Let's move that up a little bit. There we go. And then for the last one, the height is 1, right? We've got 20 and 21. That just gives us a height of 1. We want to draw a very short bar. Like that. All right. So this is a histogram. Histogram is, as I mentioned earlier, is a type of bar chart. So these are bars, and they represent the frequency, how many in this case goals there were by NCAA women from the data set. Okay, so some information about the histogram. So the width of the bars, so that's called the bin size. So that's arbitrary. The fact that I chose to make the bin size 2 is arbitrary. That's not required. You could make a bin size of 1. If you make a bin size of 1, then your histogram looks very much like a dot plot. If you make a bin size of 3 or 4, then your histogram is going to change based upon that. Okay, so if you made a bin size of 4, for example, then this first bar would go from 10 to 14, but would not include 14. Okay, so that's the bin size. That's really important. Another feature to histograms is the way in which I went through and kind of marked off the bottom here with the square bracket and the parenthesis, where I made the left side included in the bar and the right side not included in the bar. That's the default, but that's not the only way to do it. You could do the reverse. So you could make it so that the left side's not in and the right side is, but the left side being in is the default. Okay, so let's jump over and take a look at using statistical software to construct these, because you're not going to be going through and creating dot plots and histograms by hand. As you can see, it's kind of disorganized, a little bit messy. We have software for that. Okay, so the software package that we're using for this course, and if you're watching this video and you're not in the class that I'm teaching, then you'll probably want to find some, you'll find some other type of statistical software. You can, everything you can do in here, I believe you can do in Excel. So that's a very common, statistical software package. But what we're going to do is we're going to go through and we're going to construct graphs. So to go through and construct a graph, first of all, you have to get the data into the table. So I've gone through and I just took the data that's typed up on that previous page and I just entered it into a single column like this. Once it's in there in a single column, what you can do is you can go to graph and then you can select whatever type of graph you want to create. So we could go through and we could select dot plot. Once you select dot plot, what you want to do is you want to go through and select the column or columns that you want to put into the dot plot. So in this case, we want to put variable 1 because that's the only column that we've got in there. There are some options in here, group by, grouping options. So you could play around with those to see what they do. You could change the colors. Anyway, there's a bunch of different options in here, but you don't have to use any of those. All you need to do is just hit compute. And if you hit compute, boom, it creates the dot plot. So that's the exact same dot plot that we just went through and did by hand. But you can see, of course, it's computer generated, so it's a lot nicer and neater and much faster to go through and generate it. Okay, so that's how to go through and create a dot plot. We can create a histogram by going again back to graph, select histogram, select variable 1, group by, I'm sure, variable 1. So we'll talk about the different types of, we're not going to talk about density, but we'll talk about relative frequency in a minute, but we're going to leave that on frequency. The bins, so this is the important part when it comes to going through and trying to create a visual structure that matches another one that you've got. So the one that we just went through and did, I noticed I started at 10 and the width of the bins was 2. Okay, so if you go through and set these things differently, then you're going to get different graphs. And then there's a bunch of different options that you can play around with. But at this point, all you really need to do is just hit compute. Oops, that didn't work. Hold on, let's take a look at that. What happened? Start at 10 with 2. Maybe I shouldn't have selected that. There we go. And so this is the graph that we just created by hand, but generated with the statistical software. And you can see it looks pretty much the same, just much computer generated, such much neater and much nicer. Yeah, so that's how you do it. So we can go through and take a look to see what happens. The nice thing about computer is that it really quickly can go through and change the graph. So if we had done what I mentioned, which was to have bin widths of 4, how does that change the picture? You get this instead. Okay, and so the wider the bins, the more it goes through and kind of combines things and somewhat makes it harder to see the underlying structure. And so picking the right bin size is, more art than science. If you make it too small, then it basically turns into a dot plot. If you make it too wide, then you really lose some of the information that's in the data. And so it can be helpful to go through and pick a variety of different types of bin size when you're going through and trying to visualize data with a histogram. Okay, so one thing that I noticed in the homework, there's a homework problem where they ask you to create bins that are centered at a certain place and that have a certain number of units wide. And so I wanted to briefly show how to do that. All right, so let's say that we wanted to go through and create a histogram and we wanted the bins to be centered at specific intervals So let's say we wanted to create bins and we wanted a center at 9, a center at 12, a center at 15. All right, so we want them to be centered at multiples of 3, and then we want them to be, you know, 3 units wide as well. Okay, so what does that mean? Like visually, let's just take a look at what that means visually. Let's jump back over to the whiteboard. So what I just described is we want to go through and create a histogram. And we want to have a point at 9, 12. So we want the center, we want to create bars where the center is at multiples of 3, and each one is 3 units wide. So we're going to have a center here. There's going to be a bar directly above that. So we're going to have a bar directly above that. 12, we're going to have a bar directly above that. 15, a bar directly above that. All right, so we want the center of each bar to be at these multiples of 3. And then we also want the bars to be 3 units wide. Okay, so if they're 3 units wide, that means, and the center is at 9, that means we're going to have, right, if this is 3 units wide and the center is at 9, that means we have 1.5 units on the right and 1.5 units on the left. Okay, so this is going to go 1.5 units. And 9 plus 1.5, that's going to put this point at 10.5, right? So here, I'm just going to put this, we'll put 10.5. And if you're here and you go and at 12 and you go 1.5 units this way, what happens? What's 12 minus 1.5? That's also going to be 10.5. And so if you have bars that their center is every 3 and the width is every 3, then they're going to be right up next to each other. So we can actually kind of redraw this, just because this is what it's going to end up looking like. So we're going to have a bar directly between each of these. So this is what our picture is going to end up looking like. So we're going to have a bar. So what's the first bar? Where's the first bar going to start? That matters for our software package. If you recall just a second ago when we were going through that, we have 2 options for going through and setting information about the bins. And that is, we need to have the starting point, and we need to have the width. So we added 1.5 units to get from 9 to 10.5. So we would subtract 1.5 units to get from 9 down to the first starting point. So that would be at 7.5. Okay, and so the first bar is going to start at 7.5, stop at 10.5, and then 10.5 to 13.5, and then 13.5 to 16.5. Once we have that basic understanding, we can then go through and use the statistical software to create our histogram. So there's a homework problem. It's in the data set that's like this, where they go through and they give you some information and they want you to create a histogram that has bars that are in just the right place. And the way that you do that is basically like what we just did. So you'll go through and you'll start with the center of each bar. So where if they tell you where they want them to be centered, you start at the center, and then you use half of the width to go to the left and to go to the right to figure out where the edges of the bar are going to be. All right, so let's jump back over to our StatCrunch. So if we wanted to go through and create a histogram that meets that, what we can do is we can go through and say we want the first bar to start at 7.5, and we want the width of the bars to be 3 units. And if you do that and then hit compute, you'll get the following picture. Okay, so this bar is centered at 9. It goes from 7.5 to 10.5. This one is centered at 12. So the way this software works is it puts the edges, it doesn't put the center. But you can see this is centered at 12. This is centered at 15, 18, and 21. Okay, and so that's how to go through and do that, because without that information, my guess is that homework problem is really hard. Okay, so relative frequency. So the neat thing about histograms is that you can shift from a frequency to a relative frequency really easily, because the shape of the chart doesn't change at all. Instead, the only thing that changes are these values on the y-axis. Instead of representing the frequency, they're going to represent the relative frequency, or the percent of that that bar makes up of the whole, makes up of the entire sample. All right, so I'll show you what I mean by that. So let's just go into edit. We're going to change from frequency to relative frequency. And so first of all, you notice the shape does not change. The shape stays exactly the same. However, instead of having frequencies or counts for how many elements are in the bar, instead we have these decimal places, 0.4, 0.3, 0.2, 0.1. So those are just the decimal version of a percent. Okay, so this would, you could also put, instead of putting 0.4, you could put 40%, 30%, 20%, and 10%. And what that enables you to do is to look over at the bar and tell how much the bar makes up of the entire sample. So you can see that I've highlighted this. The relative frequency is 0.43 for this bar. So what that means is that 43% of all of the data lies in this bar. If you go through and highlight other bars, 22% of all of the data lies in this bar. And so on. And so you can see where that might be useful if you were going through and studying a data set and you had a histogram, and that histogram showed you the percent of the data that's in a bar instead of just the mean count of how many things are in the bar. Okay, so that is the relative frequency. Okay, the next thing we're going to look at, so we are going to actually look at one other type of, on. We're going to look at one other type of graph. It's basically like a variation on a dot plot. So it's called a stem plot. Or stem and leaf plot. Okay, so I'll just show you with an example how to go through and construct a stem plot or stem and leaf plot. So suppose we had some data. All right, here's the data set. Suppose we had this data set and we wanted to construct a stem and leaf plot. So the way that we go through and do that is the way stem and leaf plot works is you have a tens place and a ones place. You break down each data point into a tens place and a one place. So for these guys here, 1 through 8, the tens place is going to be 0, and then the ones place will be whatever element that you see there, 1 or up to 8. For 10, the tens place is 1 and the ones place is 0. For 30, the tens place is 30 and the ones place is 0. So you're going to break these down into those separate pieces. And then once you don't need to write anything to do that. You're just going to mentally do that. To go through and then organize the data, what we're going to do is we're going to put all of the different tens places basically on a vertical axis. You don't need to draw a line for this, although you could. Usually I do not draw a line for it, but what I would do in this case is there's going to be a zeros place, a 0 for the tens place, a 1 for the tens place, up through a 4 for the tens place. So I would put 0, 1, 2, 3, and 4. Okay. Once you've got all the tens places represented, then what you're going to do is you're going to go through your data set and you're going to take each element and you're going to put it into the appropriate place. So if it has a 0 for the tens place, you're going to put it next to this. If it's got a 4 for the tens place, you're going to put it next to this. And you're actually going to write the element itself. And so you can see the first guy, this has a tens place of 0 and a ones place of 1. And so we're going to put a 1 there. And then we've got 4 more of those, right? So we're going to put 1, 1, 1, 1, 1. And then we have 3 2s. And then 5 3s. And then a 4. And I'm probably going to run out of space. And then 3 5s. I could cheat and actually make this bigger. 3 6s. And an 8. So that represents all of the elements that are in our data set that have a 0 for the tens place. Now we get to the 1 for the tens place. And so we have 10. The way that that appears in the table is you put a 0. So you put the ones place next to the tens place, kind of like a row, I guess. Well, yeah, we'll call that row. I was going to say this is like a horizontal column. Well, horizontal column's a row in this row. All right, and then so we've got another 10, so you could put another 0. You've got 15, so that's a 1 and a 5, 10, 1 for the tens place and a 5 for the ones place, and then 17. All right, and then we've got for tens place of 2, we've got 20, and you've got 25. And for the tens place of 3, we have 30. And 40. Oh, I forgot to mention, I forgot to put context to our data. What is this a data? What does this represent? This represents the number of alcoholic drinks that a collection of college students said they consumed in a 7-day period. So there were students who consumed 40 alcoholic drinks in 7 days. I don't know, that seems kind of impressive. Maybe that's just me. Okay. Anyway, so that is an example of a stem and leaf. So you've got the stem. This is the stem. And these are the leaves. And you can see it's a variation on a dot plot. So with the dot plot, we put a dot for each element. In this case, we put some of the information from each element. We put the ones place for each element over on our table. So this is, we're not going to look at the data set for this. Instead, I'm just going to give you the stem and leaf and just show how you can interpret a stem and leaf plot without information. So, you know, without seeing the data set itself. So let's say you had a STEM plot. This is a STEM plot for exam grades. And this is, I don't know about other instructors, but I frequently create STEM plots when looking at my students' my students' exam results. So you could have 10 for tens place for a 10 tens place is going to represent 100. And you've got 90s, 80s, 70s, 60s, 50s, 40s, and 30s. Okay, and so then you can just go through and fill this in. So I put an 8 here, 0, 2, 5, 7, 0, 0, 1, 4, 5, 5, 5, 9. And then for the 8, we've got 0, 0, 2, 3. And for 9, 0, 0, 2, 5, 5, 6, 8. And for 10, we have 0, 0. Okay, so if you take a look at that, you should be able to discern just from looking at the stem and leaf plot what the exam results were like. Would you be satisfied with those exam results if you were a student, if you took a class and those were the exam results? I would. You could see that there's if you look at the, there's a lot of 70s, true, but there's almost as many 90s as there are 70s. So a lot of students did very well in the exam. There were 2 100s. Only one person really did poorly, scored 38. Not that scores are in the 60s are what you want, but you could still pass with scores in the 60s, assuming you do all the homework and other activities in the class. And so this exam to me, I would say most of the students here, maybe the 60 and the 62 are not the greatest, but most students here did pretty well. Okay. And so that's the neat thing about a STEM plot for an exam, is that it's really easy to go through and just at a glance see what the class distribution, which is the whole point of this section, is to visualize distribution of data to see how the class performed. There's just a little bit about the features. So you can see there's kind of 2 humps in the data. So we'll talk about that in the next section. But yeah, so that's how to create STEM plots and how to go through and analyze them. Once if you were given one where you weren't given the underlying data, so you can get from here to the underlying data, just by visually, just by looking at it. Okay, so that covers the last of the visualization techniques for this section. Thank you for watching, and I'll see you next time.